Hello and welcome. Today is going to be more of a reply to the rant that John bloated regarding entity systems and the Rust borrow checker streaming thingy. And this is not a criticism, this is actually more of an agreement. And it's also partly a hypothesis as to why I think the borrow checker isn't really a good idea in general. This is my own view. And it's a hypothesis. I don't say I'm saying the truth. I don't. And programming is so young that, again, it's like really 70 years, really, and that's just not very old at all for a profession. And my general idea about ownership semantics is that it is wrong. It's concepts apply to something without understanding the actual concepts themselves. And they are economic concepts, in fact. So that's the kind of the brief summary. And now let's go into more depth. So John talks about the problem that this woman here in this talk. So this is I'm doing a YouTube video of a YouTube video. YouTubeception, man. Yeah, no, not really. But she's talking about how the borrow checker was helping a lot in this, and she was doing it for lifetimes, and she wanted to make sure you've got entity problems, and so she's going to use handles here to reference entities and all that lot, and that's how you do it in entity systems. So the problem you've got here is a coordination problem, like a lifetime problem, a coordination problem, where you shouldn't really be having, let's say, if an entity needs to reference another entity, you don't give it pointers to that entity because those pointers may be invalidated. So the best solution they've kind of found out is kind of with handles, where this handle may be just an index to the entity in an array, or it has an index and a generation associated with it and such. And that seems to be the best one. And as John even points out in here, she's kind of said, she says the borrow checker's been helping her, and then she's kind of got around it by just making her own little pool of memory here, which doesn't really do much checking. It does, but not really. It's like you didn't need a borrow checker for that, which is kind of interesting to state. So it was kind of a little bit weird to say in the first place. So it was like, I'm not criticizing Rust either. I think Rust has got a very good kind of idea, concept, philosophical foundation to say they want to solve a problem where they want to save memory, keep safety in memory. Like they're trying to make a web browser which needs to be very safe and secure. So I think it's a very good idea. The problem is, I do think this idea that the borrow checker is great, it helps you out, even though a borrow checker is annoying when you first get used to it, but you get eventually good used to it. It sounds good. To me, that sounds like Stockholm Syndrome. And I agree with John, it's probably Stockholm Syndrome. Because you're saying the borrow checker helps you, and then you're pretty much getting around it this way. It's like, huh? But again, I'm not saying the borrow checker has no benefits to it whatsoever. It's just, to quote Thomas Sowell, there are no solutions, only trade-offs. And it's kind of like, which trade-offs do you want to take when you're programming? And if you're meant to be a good engineer or designer, you need to figure those out and understand them. So let's get down to the heart of the business of why I think ownership semantics are probably not that great, and they're applying economic principles without understanding them. So in economics, the coordination problem is solved through a market system. So you have got a market system which has got private property rights, consent, contracts. It's also got a pricing system to it. It's also got other intuitions that have been evolved over millennia, really. And there's also a lot of embedded knowledge baked into the system. So it's been going on for a long time. It's a very complex system, but with very basic principles. The issue I have, so they thought, okay, let's try and apply the concept pretty much of property rights to programming. They say, we've got these resources. I'll talk about that bit. I don't even like that word, to be honest with you. Resources, which they may have ownership over certain things. So they are property of another thing. Like maybe this entity has ownership over its resources, its components or something. Let's just say that. I'm just running a component system, whatever. Now, my issue with here, that sounds like a great idea until you start realizing, how are these entities, literally, how are they in the resources interacting with one another? Because they don't act like humans. They don't act like a market. So why are we doing this? Like, there's no pricing in this system. There's nothing like that. It doesn't make any damn sense to me. I'm like, there's no economic agents. It just seems like, what are you trying to do here? I think you've got the level wrong. And this is where some insight comes from Friedrich Hayek, one of my favorite economists. He was a Nobel Prize winning Austrian economist, and one of the insights he kind of found out was that in economies, there's kind of two tiers to the system. There's the market, and then there's the family. So in the market, it is pretty much you've got individual agents working around. It's a very bottom-up system. While in a family, it's a very top-down system. So just to state, in a family, have you ever seen the parents charge the children for food, or the bedding, or the clothing, or the water or stuff, under a certain age, of course, yeah. Like, no, that's just stupid. So there's clearly this top-down system. It's got a lot of shared resources. They all work together, but they're being controlled by kind of literally a top-down system. This is kind of very similar to the calculation problem, which is again Friedrich Hayek, Ludwig Mises, and Leonard Robbins were on the side of the I'm just saying the non-socialist side thing, and the economic planning, not the planners. They were the marketers, and they got the planners, and they're saying the planners, it's just not going to work. Like, it's physically impossible. So Mises was saying the calculation problem. This is prices are the way you can do rational economic calculations and stuff like that. Yada yada yada. I'm doing a very brief overview for people who don't know anything about economics. And then Friedrich Hayek was the same, but there's also the knowledge problem where there's no way in hell they could actually know all the knowledge, the localized knowledge they do. The closer you are to the problem, you will know more about the problem than someone else further away. You can't, and also coordinating it, which is the part of the knowledge, is so damn difficult. So it's like you cannot apply the rules you have to a family to a society, and you can't apply the rules of society to a family. That's where the problem is. So my hypothesis is they are trying to apply the rules of literally like a market to a program. But I am saying that a program is closer to a family than it is like a society, if that makes any sense. I think this kind of is from the same idea of like the same problems that object-oriented programming has. It's trying to map like the real world, and I'm saying real world in inverted commas, to programming without actually understanding the real world concept they've tried to apply, or they're trying to apply ones out of pluck them out of isolation, which actually rely on multiple others. It's this idea of not getting the right level of abstraction, which is the problem, in my opinion. And we are trying one level of abstraction and not doing it. And I think, great, we're trying different things out. That's great. We're doing a little bit of experimentation here and there. I think that's probably one of the best ways to do it. But I don't think it's probably the best. And I think it's already, you can see some issues from looking at the real world. Now, the other thing I wanted to talk about was, I said earlier, was regarding the idea of resources. Now, this is an abstraction, and it's a little bit bizarre. And sometimes, so some languages take the concept of resource, which is like, they just say it's like a resource, that we have entities, that's a resource, or a component, or memory, that's whatever. It's like, these are all resources. And it's like, so they're trying to do an economics problem again here. They're trying to just do that. But the issue is, it's like, okay, but why are we calling them resources? And it's a bit weird. The only real resources we have that are scarce to worry about is memory and speed. And also bandwidth as well. There's memory, speed, and bandwidth. Like, this higher level abstraction of calling the other is sometimes useful, sometimes it's not. But it's also, when you design a language and concepts around it, it starts getting a little bit weird. And that's where there's a lot of things going on. Like, thinking about, so let's say, an entity on a per level basis. So you allocate an entity resource and then you free that resource. I'm like, that's very rarely, very, very rarely you want to do single things at a time. You usually want to allocate in bulk. You want to do batch the allocations or stuff like that. You very rarely want to individually allocate stuff. Now, borrow checkering does kind of nudge the programmer into the idea of individual resource from batching resource. Now, I'm not saying it tells you should. It's just the very concept of itself nudges it in you in that way, which is very bit weird. When you come to resource management anyway, you start having to create a manager, And this pretty much becomes like a mini OS for resource management on your own little thing. So you create your own little mini OS, and then when you're doing that through there, then you're doing this. It's already become a top-down system. So it's already as I'm going to call it, the family structure rather than the market structure. So you've already had this system that's already working. So it's like, oh, it's not working there. But then you're trying to apply the wrong principles to the solutions that seem to naturally pop out, or the opposite. So I think this is mainly due to there are not a lack of good traditions in programming yet. And I will state this, most people are dogmatic when it comes to programming. They are. They just think, oh, this is how everyone else is doing, so it must be good, so I'll follow it, and then worship it and think it's good. Now, I'm not trying to be very clear, I'm not criticising religion. In fact, religions are very old. Most religions are very old, and they've got a lot of embedded knowledge and truth to them, and they know a lot of stuff. So when people kind of follow those dogmas, there's actually a lot of things that are there that are probably very useful, and there's also a lot of things that are very true to them. But the thing is, they've been around for millennia, and they've stood the test of time. These things are decades. That's nothing. These are literally nothing in the grand scheme of things. We haven't found those truths yet, and it's like we haven't discovered them. Like, we don't know yet. And it's just, that's kind of the problem. The culture itself is I just don't like it. It is so bad. It's like you're following, it's just fad. It's faddy. It's like, it's new fad. It's like when people find, I don't want to program scratch, so now we're going to go onto the functional thing. We have to make everything pure. And I'm like, so you've just literally got rid of one dogma and replaced it with another without actually understanding fundamentally why you had held that dogma in the first place. Well done. Sorry, but it is kind of a criticism I have. I see this a lot. It's just gone from one to the other, and I'm like, you're not understanding why you're doing it, mate. There's other philosophies that it was just experimented. Like, for instance, Unix at the time, they were trying to philosophize, saying, okay, we're going to have everything be a program, and then these programs are going to interact with other things. So we do one program that does this, and then we interact with another program and does this and this. Now, from a technical standpoint, that probably made a lot of sense at the time. But nowadays, we realise, one, we're not limited by that anymore, and also the level they're thinking about is really a function. That is a function that's doing it. It's not a program anymore. It's a function that or a procedure, or depending whatever it is. It's one of them. It's a procedure, really. I'll just use the generic term that you're passing things to. So, in this case, your program wasn't the program in the Unix level. Was technically the procedure in modern programs. Does that make sense? So the interaction is that it is the actual program. Those little mini programs are like sub-programs, procedures. So that's kind of that thing. So we've kind of learned that. It's just taken a while to figure that out, but we have kind of figured that out and discovered it. I'm just looking at my notes because I've got a few written down. Yeah, the other thing we found out again is with the entity systems and such is that handlers and the managers are a good idea. Like, in your handles, you can have an index. It could be just literally an index. It could be like simple as that. You can have an index and also a generation to it. So if that generation is dead, you're not referencing dead data anymore. So it's like, okay, we'll just leave that alone, and then we just return like the null value or whatever, like not like the zero value. So it's not, don't crash the program, but you log it, and then, or you do crash the program depending on how you want to do it. Whatever, that's fine. It's one of those where, look, I don't think there's any proper solution to this. Like, there's no real proper solutions. It's just, I don't think we have found very good ones yet in many areas. And this is not criticising this woman, not criticising John, anyone. It's just, I think we're still figuring out, and I don't think we should be stating that we have found the correct way of doing things yet. Because we haven't, by any stretch of the imagination. And there are certain things we have found that have found better, but we don't. Like, I was laughing at, this is from a few years ago, I saw when they were talking about move semantics, and he had, what's his name, Bjarne Stroustrup, or Barney Sarstup, I guess I can pronounce his name now, which is the person who created C++, and he was talking about, Why do we copy memory and then delete the original? Why don't we just move it? Even children, babies understand this. And I'm just like, no. Because how do computers actually work? Because when you're trying to solve a problem, what's the problem you're trying to solve first? And then you realize, okay, I'm trying to solve it on a physical machine. How are you doing that? When you move things in memory, you don't move it. You are literally copying it and then deleting it. So this idea that we should only move things doesn't make much sense, because it kind of it's another level of abstraction which just gets away from the computer. And it's like, you're abstracting it wrong, you're making people think about it, and you're not really understanding how this problem's going to be solved. I know there's a lot of things I've said in this the past 15 minutes, and I'm sorry, I will want to write this out properly, and I'll make a proper little essay or something, because this concept's in my head's been going around for months. I've been designing my own program language, and it's one of those things. When I first saw Move Semantics, it was like everyone has the same thing. Oh, you're fighting the borrow checker, and then it's great. And I'm like, that sounds a bit like Stockholm syndrome, mate. Really does. But it's not just that. It's like, is it really helping you at all? Or if it is helping you in certain circumstances, can you make it optional, or does it have to be language wide? I don't know. My hunch is stating you probably couldn't have it system wide. You have to have it system wide or not. And I don't know. There's other parts of my philosophy as well, which is a bit annoying, which I kind of find it weird. It's kind of like the responsibility parts to it. So it's like when people say, "Oh, I don't need to worry about free and memory and stuff." That's why people like garbage collection or automatic memory management. I'm like, no. If you make the mess, you clear it up. It's the same with error handling as well. It's like, you make the mess, you clear it up. Like I have made a little blog article on forums on the Odin channel a bit earlier regarding reason why Odin will never have exceptions. And I'm kind of stating this is literally what my philosophy is. I do hate how most languages handle errors. Treat errors like any other piece of code. Handle errors there and then, and don't pass them up the stack. You make your mess, you clean it. This is kind of my point. I'm really complaining about propagation with errors. That's my main complaint with errors handling. It's propagation and lack of information. And exceptions literally nudge towards propagation. You could just ignore them and they keep going past up the stack, literally. Return if nil. This bit here, is literally, you're just propagating it. I'm like, that's the problem I hate. And even the go-to proposal, which I'm laughing my head off, because it's like, we've got loads of these error propagation things all the time. It's error handling. Let's create new syntax so we don't have to keep writing it. And I'm like, what the? Because that's literally what's going on. Literally. I know I'm just I'm laughing here, but it's like, this is clearly what's happening. And this bit, what they've done here is you could use defer in that case. Unfortunately, defer is function exit rather than scope exit, but whatever. It literally just creates a new closure, which adds to a closure stack on the function list, which then gets called at the end. Yes, it's very weird. Usually it's pretty damn fast and it doesn't actually have to do that, but yeah, that's what it does, technically. It's like, I just kind of find this hilarious when I read it, because it's not trying to solve the problem. They're talking about Rust, and Rust has a result type, which you either have a good thing or a bad thing. Yeah, Odin can do this pretty easily now. I've got polymorphic unions, and that's probably fine. But it's still this propagation I don't like. They say, we've got the question mark operator, allows you to propagate. That's literally, I do not like that. It is one of those, I'm sorry, there's a lot of my own philosophies and just stuff. I'm not stating I know the truths or anything. It's just a lot of my idiosyncrasies and my views are kind of based on these implicit assumptions. And it's also but I would rather people say, look, the reason why we're doing this X, Y is because we think of this. And then we think, okay, can we criticize why you think of that? Not just because it's good or bad, just like, okay, can we figure out why, is that a good thing or not? Those are underlying foundations that you based. Because, again, this is just one of those things. So I am ranting. I told you it was going to be a rant. But it was, yeah, it's just one of them. So hopefully that was okay. It's been 20 minutes now. I think I'll just call that it. So I would recommend watching John's video here talking about stuff. He does, again, I agree with him pretty much 100% actually on this entirely. So there's no disagreeing with me and John here. I'm kind of given a hypothesis as to why I'm thinking the entire system of ownership semantics is probably flawed. And it's not actually helping you solve a problem. So thank you for listening, everybody. I hope that wasn't a bit boring, and I hope that wasn't a bit too much random information stuff for people who don't know anything about economics. Yeah, economics is one of my little hobbies. So thank you all for listening, and see you next time.